So, naka-connect, naka-check na yung pin connected dito. So, we have to assign. Okay, na-assign na siya. Then, that is now the footing. Okay, balik tayo sa view from Z. Then, ito naman yung i-select natin. We select that one, then new view. Okay. Then view from Y. So yung tie beam natin, that is the perimeter beam. So we have to add beam. Then kunin natin itong node cursor. Naka-add beam tayo. Then connect 7 and 8. Then 8 and 9. Then connect 10 and 11. Then 11 and 12. So connect din natin dito. Then connect this one. And connect din dito. So use the beam cursor. Tapos i-highlight natin yung mga beam. Okay, then tingnan natin yung display. So yan, naka-highlight. Tapos use the translational repeat. Then we have to move at Y. Y yung move natin. Then the distance of the tie beam to second floor beam is 3 meters. Then second floor beam to roof beam, that is also 3 meters. So palitan natin ito ng 3. Then we select number of steps, that is 2. Then press OK. So we have now the framing system here. So pareho, wala pala tayong, there is no beam at the middle for the tie beam. So wala ito. So delete natin. Then for the second floor beam, okay, so select natin yung second floor beam. Then press new view. Okay. Then view on Y. Okay, ito yung beam natin sa second floor beam. But the distance is 1.8 dito or 1.85. So meron tayong 1.85 na distance. So use translational repeat. Then Z distance 1.85. Then okay. So ito na yan. Then dito naman, yung distance natin is 2.59. So we have used translational repeat, then Z, then 2.59. Then okay. So dito, meron tayong distance na 1 meter. Okay. 1 meter yung 0.9 meter pala, 0.9 meter. So ang gagawin natin is we get yung distance natin na 0.59. So use node cursor. Yan. Then translational repeat. Then we have select Z. Then 0.59, 0.9. 0.9 yung distance natin. So okay. So ayan na siya. Then ito naman, okay, yung alley natin dito, that is 1 meter. 0.9 meter. So select natin ito, then use the translational repeat. Then we have 0.9 meters. Then we have x. So pag pa-left yung movement niya, then we use negative. Negative tayo. Then okay. Use link step. Then okay. So ito na siya. Tapos dito, 0.9 yung distance natin. 0.9 din. So use the cursor, yung node cursor. Then we have, wait, 0.9 ba dito? 1 meter pala. So 1 meter, so palitan natin. Okay, then pag pinalitan natin yung distance, since this is 0.9, it should be 1 meter. So madali lang. Use the cursor, then right click, then move. Move natin, we move negative 0.1. Negative 0.1. Mag-move tayo ng negative 0.1 so that it will be 1 meter. Okay, so pag tiningnan natin yung distance, that is now 1 meter, 1 meter na rin yan. Then, we use the node cursor, select natin ito, 0.9 naman dito. So, we use yung translational repeat, then ang movement niyan, that is negative 0.9. So, 0.9, then okay. Then, select a beam. Maglalagay tayo ng beam dito. So what we have to use there will be, palitan natin yung add beam. Okay, long press, then palitan natin yung ito. Then i-click natin. So it means that we create perpendicular beam. So i-click natin ito. Then that one. So ito na ngayon yung beam natin. Pero mayroon tayong overhang dito sa harap. So ang overhang natin sa harap, that is 1.06 meter. Okay, we select this one, ito, at saka ito. Then use translational repeat and Z. Then we have 1.06 meters. Then use link step. Then okay. Tapos, pwedeng itong perpendicular beam. So, pwede natin gamitin ito or yung add beam. So, ito yung add beam natin. Or, pag yung perpendicular beam, that is the perpendicular intersection. Okay, so ito na ngayon yung second floor beam natin. Okay, the second floor beam, na-establish na natin, then we can now have the sections, yung mga section. Okay, so yung section natin, ito, property page. Click natin, then define. Define a section, then rectangle. So concrete, naka-check yung concrete. So ang mga section natin is 0.3 by 0.3 for the column. That is 0.3. Then 0.3 din. 0.3. Then add. Tapos yung tie beam, The tie beam is 0.2 by 0.35. So yung YD niya, that is 0.35. Then yung Z niya, that is 0.2. Then add. Tapos yung beam 1, ang beam 1 natin is 0.4. 0.4 by 0.25. So this is 0.25. Then add. Pareho sila sa beam 2. So okay lang yan. Then beam 3, that is 0.4 by 0.2. So 0.4 by 0.2, then add. Then yung roof beam, 0.2 by 0.3. So ito naman yung palitan natin, that is 0.3. Then add. Okay, so we select now yung column. Ito yung column natin. And the column is 0.3 by 0.3. Then select beams parallel to Y. Ayan. So na-select na niya. Then assign. Assign tayo ngayon. Assign. Okay. Then yung tie beam. Ang tie beam naman is this one. Okay. I-face natin dito. Then we select yung tie beam. So nakaselect na tayo ng tie beam. Then assign. Yes. Then yung roof beam. Ito yung roof beam natin. And ito naman yung roof beam. So assign. Yes. Then yung second floor beam, hindi pare-pareho yung second floor beam. We have beam 1, beam 2, and beam 3. Okay, so select natin dito, then use the new view. Then okay. Then view from Y. So ito yan. 4.4 by 0.25. Pareho yung beam 1 at saka beam 2 ng section. So beam 1 and beam 2 will be this one. Ito. We have this one. Ito. Then ito naman. At saka yan. Yan yung beam 1 at saka beam 2. So ang beam 1 natin ito. Then beam 2, ito naman. Okay, so na-select na natin, then assign. Assign. Then we have beam 3. Ang beam 3 natin, we have this one. Ito. Then, yan. Ito naman yung beam 3 natin. By the way, select muna natin. Okay, so we have beam 3. Ayan. Yan yung beam 3. So nakaselect na, then assign. Okay, so we have now the sections. Mayroon tayong mga section. So if you want to view the section, then ito yung gagamitin natin, the 3 render view. So pwedeng itong 3 render view, pwede rin itong structure, then section outline. Then i-okay natin. So yan yung section outline natin. Hindi pa natin na-check ito. So by the way, ang section natin doon is section. Yan. So then assign. Okay, meron tayong section. So pwede rin dito pag gusto nating tingnan yung 3D dimensional view. So ayan siya. Okay. So next is to identify the structure. So ang loading natin, since this is now a three-dimensional, we can now incorporate earthquake here. Meron na tayong earthquake. So to do that, we have here command. Then itong loading. Then definition. Okay, so command, loading, definition. Then yung seismic load. Ito, seismic load. Tapos, kunin natin dito, we have the 1997. So we'll be using on the UBC, that is the Universal Building Code. So ito yung pinaka-latest niya. UBC 1997. Okay, so from here, meron tayong value ng Z. So that is the zone factor. Okay, since wala pa kayong earthquake, the zone factor is 0.4. Ang zone factor natin sa Ilocos Norte is 0.4, wherein that is zone number 4. So palitan natin ito ng 0.4, then that is 0.4. Then importance factor, pwedeng 1, pwedeng 1.2. That depends on the type of structure. Since importance factor natin for residential, that is equal to 1. Then RW, yung RW naman dito, this is not 3. So dito, this is for the US. Kasi ang 3 dito, this is, yung gamit nila, that is, they are using the English system. English system sila. But since we are in metric system, our value of RW is 8.5. So 8.5 tayo dito. So we have 8.5. So 8.5 din dito. Then soil profile type. So in soil profile type, that is depending on the type of soil. Mayroong hard clay, may soft clay, may stiff clay. But what we have to make use on this is if we don't have data regarding the soil profile type, ang sinabi sa NSCP, okay, these are from the NSCP. Yung mga valueng nilalagay ko dito, this is taken from the NSCP. So from the NSCP, if the soil profile type is not available, then we can make use of SD. So SD is number 4. So ang SD natin dito, that will be number 4. So bale, SA, SB, SC, SD. So yan yung kukunin natin. Then yung near source factor, nandun din sa NSCP. Okay, so in this case, we will just use 1.2 and 1. That is the near source factor. So yung C sub T, it can be computed. Pwede natin i-compute dito. Pero mayroon tayong asterisk dito. Ang asterisk doon, pwedeng hindi natin lagyan or pwede rin natin siyang lagyan. But the value of C sub T, that is 0.0756 multiplied by h raised to 3/4. So 0.0756 multiplied by the height of the structure, that is 3 plus 3, that is 6, times 6 raised to 3/4. then that is 0.29. So we can put here, ito 0.0738 pala, 0.0738. So ayan, 0.0738. Then ito naman, itong 0.0738, that is ang NSCP, nasa NSCP ito. Then itong period in X and Z direction, that is T is equal to CT multiplied by H n raised to 3/4. Yan yung sinabi kong 0.29. So that is 0.29. 0.29 din ito, 0.29. Then we can include accidental load. So yung accidental load that will be due to the yung beam natin or yung slab natin hindi uniform, pwedeng mayroong mas makapal na beam, pwede rin na mayroong mas manipis na beam. Or when yung slab, when the slab is not fully loaded, mayroon tayong mga di agdan, di ba? Tugtagdan di ka awan ti slab na jay. So in this case, ito yung include accidental load. So we can check on this, then add. Okay. So seismic load parameters can be defined only once in staad model. Then close. I-close natin. So andito na yung seismic niya. Then from that, pupunta na tayo ngayon sa loading. Load command. Ayan, load command, then primary command. Itong primary command ang ilagay natin ngayon. Okay, ang primary command natin, unahin natin palagi yung seismic. Seismic ang mauuna dito. Since hindi niya i-run pag nauna yung dead load at saka live load, nahuli yung seismic. So what we have to do here is unahin natin yung seismic. So ito yung seismic load. Then load case 1, that is earthquake load. Earthquake from X direction, from positive X. Okay, positive X. Okay. Load case 1 natin, earthquake from positive X. Kasi yung earthquake, paiba-iba yung direction niya. So that is coming from the left. Then pag bumalik siya, that will be coming from the right. So sinsinublat. Kaya meron tayong positive X at saka negative X. So that is add. Then yung pangalawa, seismic, then negative PQ. EQ negative X. So yan, EQ negative X. Add. Then next is the seismic pa rin. So seismic, but that will be now PQ at the Z axis. So we have EQ, then negative Z axis. Then add. Then next is seismic pa rin, and that is EQ from the positive. Okay. Then from the positive z-axis, add. Then ang susunod, we have the dead load. Itong dead load. Dead load. Then add. Then next is the live load. So ang live load naman natin, ito, live load. Then add. So okay na yung mga loading natin. We have the earthquake along the x-axis coming from the left. Then the earthquake along the x-axis coming from the right. Then we have the earthquake coming from the top. Then the earthquake coming from the bottom. Then we have the dead load. So ito yung dead load natin. And we have the live load. So okay na tayo dito. Then we have now here the load. So ang load natin, we have the dead load. Load case 1. So load case 1 add. Ang load case 1 natin, our load case 1 is positive. So we have the self weight, then yung seismic, ayan, seismic. So ang seismic natin is, the factor there is 1, or that is positive 1. So x direction, then add. Then we have load case 2, add. The load there will be, okay, ang load natin is seismic, then negative, x negative ito. Then negative, then add. Then we have load case 3. Load case 3 is add seismic. Okay, our load case 3 is negative, z. So we check on z, then negative, then add. Then load case 4, seismic. Ang load case 4 natin is z. Ayan. Then positive. So positive, so add. So for load case 5, our load case 5 okay, load case 5 add. Our load case 5 is, we have the self weight. So mayroon tayong self weight. So yung self weight, we have the weight of the column, the weight of the beam. Then ayan yung mga self weight. So i-add natin ito, that will be negative. Negative yung factor niya para yung loading will be downward. So we have add. Tapos Yes. Save. Ayan, nakalagay na yung self-weight. Then, yung roof natin, ito yung roof. Okay. Meron tayong, we have here a weight of the roof. So, yung roofing natin, matra-transmit dito sa beam. Matra-transmit dito sa beam. So, therefore, we have area loading. So, area yung gagamitin natin. Floor area pala. Floor area yung gagamitin natin. So, that is floor area. Then, global Y. So, the pressure, ang pressure sa floor area, so, magko-compute tayo. But, i-assume na lang natin. So, dito merong computation ng loading. Okay, i-assume na lang natin na 3 kilopascal yung dead load. Okay, so yung height nito is, the height there is 7.5 meters. Okay, so we have, yung pressure niya is 3 kilopascal, tapos the height is 7.5 meters. So that is 7.5 by 7.5. So the minimum height 7.5, the maximum height 7.5. So dito lang siya sa roof. So since loaded lahat yung sa roof, then 0 ang mga ito. Then add. So add na natin. Ayan siya. So we have 7.5 F load 3 GY. Then yung sa second floor beam, ito yung second floor beam. So select natin yung second floor beam. Select. New view. Okay. So ang mayroong load dito will be, ang mayroong load will be at a height of 4.5. So 4.5 yung height. So therefore, palitan natin yung height. This will be 4.5. So 4.5, then 4.5 din. Tapos yung pressure, okay, so medyo mas malaki yung pressure dito. Let's consider that the pressure here is say 6 kilopascal. So 6 kilopascal naman. Okay, anyway, these are just an assumption on the load. Pero as I've said, there is a computation. So meron tayong computation dito. Okay, so from that, ang merong load will be, dito walang load. There is no load on here. So what we have to do is get the coordinate here. Ang coordinate ng x niya is 0. Okay, so palitan natin dito ng 0. Okay, that is 0. Then, ang z coordinate niya, that is 0. So 0 din yung z coordinate. Up to this point. Okay. Ito naman. The value of z, ang z natin is 2.75. So, xz. Palitan ito ng 2.75. 75. Then ang X niya is from 0 to 5.18. So X is 0, then up to 5.18. So ito naman, palitan natin 5.18. Then add. Okay, yan. We have 4.5, 4.5, F load 6, X range 0, and 5.18. Then Z range 0 to 2.75. Okay, so mayroon na tayong load hanggang dito sa portion dito. So the next is we get yung X distance natin dito, or Z distance. The Z distance is 2.59. So palitan natin ng Z distance dito of 2.59. Then ang Z distance naman natin dito is 6.24. Then we have 6.24. Then that is from 0. Ang X distance natin is 0. So 0 up to 5.18. So pareho. 0 up to 5.18. Then yung Y niya, that is 4.5. So okay na dito, then add. Then so another loading that we can apply here is the member load. So itong member load naman. Okay, unahin natin sa taas. Member load. So on top we have this one. Then new view. Okay. So ang member load natin, when we say member load, the beam will carry loadings. Ang loading na kine-carry ng beam dito sa perimeter will be the partition, yung mga hollow blocks. So again, yung hollow blocks, i-compute natin yung unit weight ng hollow blocks multiplied by the height of the hollow blocks. So that will be in terms of kilopascal din. Okay, so considering na lahat nito is meron tayong partition dito. So we get all of this. Kukunin natin. Then yung load natin na in terms of kilonewton per meter pala. So in terms of kilonewton per meter, okay, considering that that is 3.79 kilopascal, kilonewton per meter, then GY siya, so add. Okay, yan naman yan. So that is the value. Then on the second floor, okay, second floor, new view, okay. So dito sa second floor, ang meron lang tayong load will be the perimeter. Okay, so i-select natin ito. Meron load dito. Meron dito. Then we have this one. Meron tayong load dito. Then meron din tayo dito. So we have a load here. Then load dito. At saka load doon. So dito wala na tayong load because walang hollow blocks dito. So therefore, ito lang yung mayroong load. Then ang load natin is 3.79 times 2, so 7.8. 3.79, so 7.8. So yan naman yung load doon. So 7.8. Then add. So naka-add na tayo dito. Ayan. Hindi. Hindi pa na-load. Okay, so ang self-weight natin is, okay, magkita tayo na nga certificate opening. So opening data. So ang self-weight, we have self-weight assigned to view, then assign. Yes. Uniform GY. So GY natin is sa taas. So ito, GY. Assign. Then ito naman, second floor. So ito, this one. Ayan. So assign to selected beams. Okay. Baliktad yung nagamit natin na load. So i-edit natin. This will be negative. Negative ito. Change. Okay. Then yung isa naman, ito negative din. Edit. Negative. Change. And this one, that is also negative. Edit. Negative. Change. Then ito, negative din. So negative. Change. Ito negative din. Edit. Negative. Change. Then balik tayo dito sa definition. Okay, save natin. Save. So we can make use of this staad editor to edit. I-edit natin. Okay, for the dead load, ang dead load natin is dead load ito. Load type. Okay, we get this one. Get natin ito, then copy. Copy. Then from the definition of the seismic definition, okay, nasaan yung seismic definition natin? O, dito. accidental, okay, dito natin ilagay, type, then i-paste natin, paste. So, self-weight, hindi self-weight ang, okay, self-weight natin is 1. So, palitan natin itong y is equal to -1, then palitan natin ito ng y, ng 1, that is simply 1. Kasi yung self-weight niya na 1, ang i-compute niya dito will be the yung seismic. So we don't have to place their negative value. So ang floor load, y range, so floor load, okay, so dito we have self-weight, that is 1, then y range 7.5, 7.5, okay, so natin staad editor. Okay. For the yung okay, ito yung floor load. We will ang command na gagamitin natin dito, hindi pa ito yung load. So the command that we will use here is floor weight, WEIGHP. Floor weight, then Y range 7.5, 7.5 F load. So we move here, or we change here to that is -3. So this will be 3. Kasi tikom computer na pelang gatwik at dijay earthquake to pelang tikom computer na. So hindi pa yan yung load, but that is the weight. Then ito naman we have -5, -6. So gawin natin +6. 6, that is 6. Then wala muna yung GY. So delete GY. So ito we have +6. Then wala yung GY. So that is the floor weight. So ito naman, that will be member weight. Okay, so that is member weight. And tanggalin natin itong GY at saka yung negative. So ayan. So positive muna siya. Then tanggalin natin yung GY at saka negative. Okay, positive na siya. Okay, so for the live load, ito yung live load natin. Okay, so enter. Then, kopyahin lang natin yung dead load. Mas putrope lang. So, yung dead load, ang dead load natin is ito. So, we have okay, kahit ito, itanggalin natin yung list all. Pwede. So, self-weight, y negative 1, f load, that is the dead load. Then, yung live load, okay, ito lang yung kukunin natin, yung floor load, ito lang. So, since for the member load, wala naman siyang carrying member load na yung live load for the wall. Wala tayong live load for the wall. But what we have there is yung dead load for the wall. So ito lang yung kunin natin. So we have copy, then i-paste natin dito. Paste. Then yung value ng live load, papalitan natin. So for the roof load, ang roof natin that is 0.7 to 1 kilopascal. That depends on the roof slope. Kung yung slope niya nagbabago, so the value of the roof load will change. So maximum there is 1. Then for the live load for the residential, ang live load naman ng residential that is 2 kilopascal. So 2 kilopascal, palitan natin ng 2 kilopascal. Then from the itong UBC load times 1 kung ana. Okay, so i-perform natin ng analysis, perform analysis. Then enter. Tapos change. So we have there change. So all the lahat ng seismic load, we type perform analysis and change after the seismic load. Ang seismic load natin yung UBC load X1, UBC load X-1, yan yung mga seismic load. So i-copy natin ito. Then dito, paste. Then ito naman, paste. So manon, 1, 2, ito pa. Then paste. So we have 4. The 1, 2, 3, and 4. Okay, so finish na tayo dito. Then, save. So, nakasave na pag napalitan yung kulay. Yellow kanina, ngayon green na. So, nakasave na. Then, i-exit na natin. Okay, so ito na yan. So, we have to make use on the load combination. So, kunin natin yung load combination. So, we have command. Then, punta tayo sa loading, load combination. So, automatic load combination. Ito yung kukunin natin. So, the automatic load combination. Okay. ACI generate load. Create repeat load cases. Then, check natin yung create. Tapos, itong mga combination natin. So, we have 1.4 dead load, 1.2 dead load plus 1.6 live load. So, tanggalin natin ito. Then, tanggalin din natin yan. Okay. Detoy. Then, 1.2. D. Data kaya. Tapos, 1.2 dead load, 1.6 live load. One point two, 1.6. Madasin naman dito, table 2, generate, damit lata. Table 8, generate, okay, table 1. Okay, so, dito tikatin tayo, data. Dito yung survey na dito yan. 1.261. Then, so, i-add tayo dito. Okay. Then, i-edit tayo dito kasi pagda Madina. Okay, so we have 1.4 dead load, then 1.2 dead load, 1.6 live load. Then, 1.5 dito eh, katem tayo dito eh. So, make cut dito eh. Then, ito we have 1.2 dead load plus 1.4. 1.6 comma dito eh, 1.6. Okay. Tapos the earthquake. Then, 1.6, 1.6, then 1.6. So, yan na yan. Then we have save natin. Then exit. Then we have command, design, no, analysis, perform analysis, yung hindi yan. So we have command, then analysis, ito, P-delta analysis. P-delta analysis, number of iterations, so gawin natin 5. Then, okay. So, check natin yung editor. Okay, so we have P-delta analysis. Then, finish. Okay, so after that, we can now make the analysis. So, run analysis. So, nag-run na yung analysis. Then, done. So, processing. Okay, ito na yan. So, we can determine now the load. So, in load case, yung mga dead load natin, ito yung dead load natin. Para makita natin yung load or dead load, i-click natin ito. Ayan yung dead load. Yung wind load pala. Medyo masyadong malaki. Lintan natin yung loading natin. So we have scale of the load, point load, apply immediately, point load, then yung rotation, moment, point moment, then ito, point load. So ayan. So if you want to determine the value, okay, ito, then value. Check natin yung value, then apply. Okay. So ito na ngayon yung earthquake load natin. So we have now the earthquake load. Kanina, pag hindi pa natin nuantay pengin run, awampay digitoy. Ano parang digitoy earthquake load na. So since na-run na natin, then ito na ngayong mga earthquake load. Meron na tayong earthquake load dito. Then yung accidental torsion, ito naman yung accidental torsion niya. So digit accidental torsion. So that is for load case 1. Our load case 1 is coming from the yung earthquake that is coming from the left, left to right. So left to right sunod ta. So for earthquake 2, it is now coming from the left to right. Itimet pagkapon na nawa. Then for earthquake 3 that itimet Z. Itimet Z direction. So that comes from the negative Z direction. Then nadigemet positive Z direction, datamet pagkapumet ito. So yan naman yung earthquake load natin. Okay, so that is the result of the earthquake. Then yung dead load natin, okay, so take note that the dead load, ang inilagay natin na load will be the area load. Yung area load ang inilagay natin. Pero yung area load niya, i-compute niya ng triangular load at saka trapezoidal load. So ito na ngayon yung load natin. So the load will be computed based on the trapezoidal load at saka triangular load. So dead load ito, then we have the live load. Ito naman yung live load natin. So yan yung live load. Okay, kinompute niya ng triangular load at saka trapezoidal load. So ito yung opening natin. Wala tayong load sa opening. Then yung combination of load, yun na yan. So we have the generated combination of load. Okay, so if we compute for the or get the result of the yung result ng dead load or the result of the combinations of the load sa roof beam. Okay, we select yung roof beam. Okay, ito yung roof beam natin. Select natin yung roof beam. Then, new levels. Okay. So, ito yung roof beam natin. We can make use of so, pwede tayong gumamit ng Excel. So, the result can be saved in Excel. So, pwede nating save sa Excel yung result. Okay, so ito yung result natin. Okay, for the roof beam, halimbawa yung roof beam, kukunin natin yung roof beam. Okay, kukunin natin yung result ng roof beam. Okay, so dito ginamit ko yung Excel in finding the result of the analysis. So, insert. Okay, we select all the roof beam. Ito yung roof beam natin. Select natin lahat. Then, make a report. So, beam and forces. Yan. Then, loading. Ang kukunin natin will be the combination. So, since yung mga primary load, yung dead load, yung seismic load at saka live load, maliit lang yun. So, the one that will give the maximum result on the moment will be based on the combination. So, tanggalin natin ito. Then, ito na ngayon yung maximum result natin. Lalabas dito yung maximum result. Then, okay. So we have now this one. Then i-click natin ito, then select, then copy. Tapos pupunta tayo dito sa result. Result. Ayan. So on the result, paste. Okay, so ang lumabas is 55.97 maximum, then yung minimum 58.63. So yung maximum at saka minimum, that is based on the left and the right. So ito, this is based on the end moments. End moment ang mga ito. So hindi natin alam yung middle. So the moment of the middle of the beam is almost one half on the maximum moment. So ang maximum moment natin dito is 58.63. So the maximum moment at the middle is one half of 58.63. Okay, ang nag-maximum dito is 58.63, 38. So yung 38. Okay. What is beam number 38? Shape B. Ito yung beam number 38. Bending. Okay, beam number 38. And number 13, load 13. So, beam number 38 and load number 13. Bending and C. Ayan, 58.63. So, pag tiningnan natin dito, ang moment niya, 27.125. Okay. 27.125. 58 divided by 2, that is about 26. So almost one half kung nagtatay. So that is the moment at the midspan. Okay, kitang tadi duma. Number 13, number 12. Okay, 26.958 beta. So dagdakkel pa lang tayo sa stat. May sagat 20, number 13, 27.069. So na-line temet dito'y mesa 25.44. So that met 25.44, 10 ijay 25.395. So that met mesa nga load combination 23.216. So the maximum positive moment is that is on load number 13, and that is 26.8 26. Yata 27.084. So that is almost one half of the maximum end moment. Hello, Padre. When nagloko dito sa cellphone ko. Nagloko nga min sa cellphone ko. When when into nila bigat basirin padre ket madama pila klase. Sige padre. Sige padre. When nagloko kami kay cellphone ko padre. Sige padre. Okay, so the maximum positive moment is almost one half of the maximum negative moment. Okay, ito take it, nakita tayo nga moment na to 58.63. So, ang moment dito is okay. Take note on the moment. So, negative ko na to, negative 58.625. But the actual moment here is not negative. Although negative siya, pero kabaliktad na naman to yan. Kasi dyan what chord na. So, ijay bangir na 15.36. Okay, ijay bangir na 15.36. Number 20. 15.36 decimeter. So, the result na ito'y positive. Positive sunod ito'y di mesa negative. So, actually, they are both negative. Negative na nagpada. Ngayon, the direction da opposite. So, yan yung result ng analysis dito. So, yung negative dito, that is an beam number 38, node number 23. So, ang node number 23 natin nasa right, node number 20 dito sa left. So, ang node number 20 is sa left. So, yan yung 15.36. Yung moment na naman ito, agad ti baba, ang dami ta baba. So, the positive moment tayo, that is about one half of 58.63. So, makita tayo met, nati positive moment na 27.084. So, 27 times 2, that is 54. So, that is almost the same with one half of the positive moment. Okay, so what I did is, kinuha ko itong, okay, yung 58.63, then yung design natin ng beam, okay, beam design ito, so roof beam, ang roof beam natin is 58.63, 58.63. Okay, data no kwanti beam tayon. So, medyo atidog dijay. And in this case, we can change the section. Pwede tayong mag-change ng section dito. If we use the roof beam that is 350, then we have 5 number 16 na wadyayan. Or actually, that is minus 1. Tama, 5 na siya. Then, palitan ito ng 5. Then, ito na ngayon yung sinasabi ko kanina. Yung positive, yung midspan natin, the moment at the midspan is almost one half the moment of the maximum moment at the end moment. So, ang end moment natin is 58.63. So, one half of 58.63 is 29.315. So, that is almost the same as yung 27.084. So mas malaki pa yung ginamit natin dito, so mas okay. So on the design, mas okay kung mas malaki. Then, i-change natin ito. Okay, so that is 5. Then dito, that is 3. So ang lumabas is tatlo rin sa midspan. So at midspan, we check on this. That is, so 3 na yung midspan. So therefore, the result now on the beam is, ito na ngayon, 5 number 3, 5 number 16, and 3 number 16 at the bottom. So ito naman, we have 3 number 16 on top and 3 number 16 at the bottom. So yan yung result niya for the design. For the analysis, I get the analysis from the staad. So ito yung staad. By the way, hindi ito yung loading kasi natin hindi ko i-base sa computation. But if I will base on the computation, yung loading, the computation of loading will be in here. So I use the Excel in computation of loading. So this one is sa ipinakita ko. Okay, we have 25 square meter per area, that is 100. Length of the beam, that is 30 meters. Roof beam 0.2 by 0.3. Floor beam 0.25 by 0.4. Length of wall 22.5. Size of wall footing 0.4 by 0.15. Number of column 6. Size of column 0.3 by 0.3. Then ground column, that is 3. Upper column, that is 3. Number of floor, that is 2. Then slab, that is 100. Okay, ang load natin dito will be this one. Ang pressure load is 0.9 for the roof. Then ang member weight, that is 3.9. Okay, yung 3.9. So on second floor, the pressure load is 3.5. And the member weight is 7.8. So palitan natin itong result natin kasi medyo malaki yung dead load natin kasi. Ang dead load natin is dead load. So our dead load is so 0.9 at saka 3.5. 3.5 and 3.5. Then this is 0.7. Then 0.9, 3.5, 3.5. Then analysis, run analysis. Done. Then processing. Okay, yung kinuha natin is roof beam, ito. New view, okay. Then we have report, beam and forces, loading. Loading natin. Ito, so we have okay. Then copy. Tapos i-paste natin sa ito. So we paste in here. Then tingnan natin kung ano na yung maximum moment. Paste. Copy. Paste. So 41.7 na. So the maximum moment is now 41.7. Then we have, palitan natin yung moment natin dito. Beam. So 41.7 na. So wala na itong plus 1. That is now 3 number 16. Then 3 number 16. So plus 1 tayo dito. Okay. And so yan na ngayon yung section natin sa beam. Okay, so any question on the analysis of 3D frame? Okay, ang question, lak nga rin attendance yun.